The last family of functions we're going to look at under the category of algebraic functions are the rational functions. And a rational function is basically the quotient of two polynomials. For example, f of x equals 2x to the fourth minus x squared plus 1 all over x squared minus 4. Now, when we had polynomial functions, you'll recall that those were these really beautiful smooth curves, and they were always connected, right? They had all real numbers as the domain, but that's not the case in general with rational functions. If we look at this example, there are a couple of numbers that are going to cause us to have a denominator equal to 0. In fact, those two values are x equals 2 and x equals negative 2. So our domain is going to be the set of numbers x such that x cannot equal negative 2 and x cannot equal positive 2. And this changes the graph. It makes it different from what we would expect with a polynomial. Let me give you a quick sketch of this one. Now, at positive 2 and negative 2, those are not a part of the domain. And what happens here, and in most cases, when a number is not in the domain of a rational function, we end up with vertical asymptotes. And in this particular graph, the middle part of the graph approaches these asymptotes downwardly, and then the sides approach upwardly, but then the graph does go off kind of in its own direction over there. So this is a very quick sketch of the graph of this function f of x. With rational functions, we often have vertical asymptotes. It's also possible to have horizontal asymptotes. In fact, we've already seen an example of a rational function in a previous video. F of x equals 1 over x is also an example of a rational function. And that one we saw had a vertical asymptote and a horizontal asymptote. So it's possible that we also have horizontal asymptotes. It is also possible to have diagonal asymptotes, where we have a diagonal line and the graph is getting closer and closer to that line. I don't know the equation for one off the top of my head, but there are absolutely rational functions that have vertical and slant asymptotes that look something like this. Again, these are just very quick sketches. There's a lot that can happen with rational functions. Typically in an algebra or a pre-calculus class, you'll spend a good week or so looking at rational functions. So we're just doing a very, very, very quick glance now. If you want to spend more time looking at more examples of rational functions and the different types of asymptotes and when they occur, you're more than welcome to do that, but it's not really necessary right now. Again, I just want us to review a plethora of things that you should have seen before, things that I'd like to remind you of. Now that we have seen all of these different families of functions, I want to talk about algebraic functions in general. And I'm going to give you the definition of an algebraic function. A function f is called algebraic if it can be constructed by combining polynomials using algebraic operations, meaning addition, subtraction, multiplication, division, exponents, and roots. So everything we've seen so far counts, but we can also break out of some of those strictly defined categories we've just seen and combine these functions in interesting ways. For example, f of x equals the square root of x squared plus 1 is the square root of a polynomial function, and that counts, right? We can take a root of a polynomial. Or we could look at something more complicated. G of x equals x to the fourth minus 16x squared all over x plus the square root of x, and then plus x minus 2 times the cube root of x plus 1. I know there's a lot going on here, but each part of this is either a polynomial or a polynomial inside a root. X itself is a polynomial, so that being inside a root is fine, and adding another polynomial to it is fine. These are, even though this is complicated, it still counts as an algebraic function. We're going to next be looking at a category of functions called transcendental functions. And what we're going to see in this other category, these are definitely not algebraic ones, are functions that we cannot construct with just polynomials and these different operations. For example, trigonometric functions, sine of x or tangent of x, exponential functions like e to the x, logarithmic functions such as log base 2 of x. Things like these, which hopefully you've seen before, are their own thing. These are not things that we can make out of polynomials. They're more complicated than that. And so these ones are not algebraic, and that's why in the next lesson we're going to talk about these categories of functions which fall under the umbrella of transcendental functions.